Welcome to this Fundamentals Lesson Plan series on structural, layout, and design. In this video, we'll take a look at placing structural columns and beams. This is video 1 of 4. My name is John Harridge, and I'll be your host for today's lesson. Let's look at the learning objectives for video 1. At the end of this lesson, you'll be able to place columns to support a raised outdoor deck. And then second, we'll take a look at placing beams as primary members to support floor joists. With that, let's get started. Let me begin this exercise with an instructor demo, so just please watch. In just a few moments, I'll demonstrate on screen the key differences between architectural columns and structural columns. One unique function of structural columns is that they carry engineering data to perform analysis downstream. So that's something that an engineer would perform. So let me show you what's going on here. The left window is a plan view, so it's level 2, and the right window is an elevation view that has some elevation datums in there to work with. Now let's take a look at where the column tools are located in the user interface. One place is on the Architectural tab in the Build panel. You'll note that there is a column tool up above. It also has a pull-down menu associated with it. And the first one is the structural column tool, and the second is the architectural column tool. So they do have their own unique tools for placement based on those two distinct behaviors. So let's take a look at the architectural column first. And by default, scanning the options bar, architectural columns like to be modeled towards the sky. So that's why it has a height set as a default, and then you would assign it either a constraint or unconnected for a fixed distance or height. Next up is the type selector. This is where you would choose the member shape that you wish to place, and these are the ones in the template. Otherwise, you could load a family to load additional shapes. So to place, we go to the plan view and left click to place an instance. And notice that as soon as it's placed, it also has a representation of the same object appearing in the elevation view. So if I select the column in plan view, there you go. Now it's highlighting in the elevation view just to demonstrate it's one and of the same object. And notice that it's going from level 1 to level 2 as we told it up front. Next, let's take a look at the structural tab and finding the column tool in the structural panel. This time there's only just the structural column tool. Let's take a look at that one. Scanning the options bar has similar functions, but note that structural columns like to be modeled in a downwards orientation. So that's why it's set to depth. And again, you would assign it a constraint or a fixed distance when you set it to unconnected. Again, the type selector is there to choose the member shape that you wish to place. Again, you can load additional families to get additional shapes. Now, if I move into the plan view and left click to place an instance, note in this case I do receive a warning message that I did not receive with the architectural column. It's just letting me know that this element is not visible in this view. And one likely source for that reason is probably the view range, which controls how much information we actually show or display in that view. But if you look in the elevation view to the right, you'll note that the column is there, even though it shows up as a stick figure or symbolic line. And then the architectural column up above, just to the left. All right, so let's take a look at why we're not seeing the structural column in plan view. So if we go to the view properties of the plan view, under the extents section, you'll notice that there's a property called view range, and the view range is what controls how much information is displayed in a particular view. So opening that up, we note that the bottom, if you will, of the view is set to the current level, and it's set at 0, so there's no offset either way. And the cut plane is actually set at 4 feet above the current reference level. Now there is a way to modify the view depth to actually go beyond the current hosted view plane by actually modifying that to put in a negative value. So if I put in -2 feet, and then hit the apply button to apply the offset. Note that the structural column now appears in the plan view, whereas before it did not. So again, it was that negative offset value that allowed that plan representation to appear. So to summarize progress thus far, architectural and structural columns have their own placement tools, and also default behaviors are different. Next, let's confirm that these truly are unique element categories. So to demonstrate this, I'll go into the View tab and open up the Visibility Graphics override. So these are display overrides for the current view, and I'm looking at the model categories and just scanning that. You'll note that there's a column category, and if I unmark that and apply that visibility change, the structural columns remain, but the architectural columns did hide in this view. So let me reset that. So architectural has its own category, and then scrolling down you'll find the structural column category. I'll go ahead and unmark that and apply the visibility state to the current view. And again, note that the structural column is now hidden. So indeed, they are two different categories. So just resetting the view, I'll go ahead and dismiss the dialog box. Next, let's take a look at the display properties of architectural columns and structural columns, and in particular the structural columns. So no matter how close in I zoom into the structural column, it just shows up as schematic line work. And even if I toggle the thin lines mode, I'm just demonstrating it's just single symbolic line work, if you will. So let me turn thin lines mode off, and let's discover what's the answer to this solution. It actually lies in the view control toolbar. If we change the detail level from coarse to medium, then I actually get the two-line work representation for the width of the structural column. So again, that's a view dependent property. We would also need to repeat that again in the elevation view to have the same level representation. All right, now let's take a look at the constraints. So there's a base constraint. So we're working from level 1, and the top of the column is working towards level 2. So those are parametric relationships that have been established when the columns were placed. Note also that there's an opportunity to modify those with offset values, either from the bottom or from the top. So just to put this into motion, if I set the top offset to -1 foot and apply that, I want you to understand that that's actually a persistent relationship. So that gap distance of 1 foot will always be maintained no matter where level 2 elevation truly resides. So we'll put that into motion here in just a few moments. And just to help illustrate that point, let me go ahead and dimension that gap between the top of the column and that level 2 datum, so you can verify that it's truly 1 foot. All right, so let me modify some elevation datums here. Let's start with the bottom level. Let me go ahead and select that and edit its value. Let's maybe bump that up 1 foot. And note that the bottom of the architectural column and the top of the structural column still maintain that relationship to level 1. Okay, so that's maintained. Let me reset that back to 0. And let's move on to the top constraint illustration. So if I change level 2 to 12 feet, just note that that 1 foot gap is persistent. Last, let's take a look, another further look at structural columns. So can we place structural columns going in a vertical direction? Yes. So if I start the structural column tool and change its direction to height, I just need to set the constraint to a level that's currently above the current level and go ahead and place another instance in the plan view. And I'll just end the command and I'll zoom in and just note that the line work is bolder, and that's because the column actually crosses the cut plane at 4 feet. So even if I turn the thin lines mode on, we get that 2-line representation for the structural column. And again, in the elevation view, if I want to see that 2-line representation, I have to change the detail level to medium. Okay, this concludes this instructor demo. Please now join me in the hands-on part of the exercise. To begin this exercise, let's go ahead and open up an existing project file. Go ahead and click open and then browse out to your tutorial folder. And let's open up the structural exercise 1 project file, please. If a warning message comes up, just go ahead and ignore the message to continue. In this exercise, we're going to place columns and beams to support this raised outdoor deck. Let's take a look at this from a 3D view. If you open up the generic 3D view and then use the orbit tool to rotate to the back side of the house, you can see the raised deck there off the main level. Again, the idea is to put in structural column supports to take that load to the ground so it's fully supported. So we'll place columns first, and then we'll place beams that are part of that system as the second series. To begin, let's go back to the deck framing plan view. And to make it easier, let's go ahead and we're going to place these floor systems in a temporary hide state. So if you left click to place one in a selection set and go to the temporary hide tool and then choose hide category, then we're hiding both those floor systems and just letting you know that we're in a temporary visibility state mode that's not persistent when you save the project. So to locate the column tool, go to your architecture tab, build panel, and click on the pull down menu and go ahead and choose structural column. In the type selector, we want to change the size to a 4x4. Let's go ahead and select 4x4 and then scanning the options bar, just confirming that the columns are going to be modeled in a downward orientation, so it should be set to depth. And for the level constraint, it should be set to basement. So we'll make sure that's confirmed. And so we want to place columns along grid line A. So if you need to, zoom in if you want, but we want to acquire the intersection snap at grid 1 and grid A. So go ahead and left click to place an instance. Move over to grid 2, left click at that intersection to place another instance. Move over to grid 3, left click to place another instance, and then grid 4, this time we want to jump over to grid line B to place an instance there. So let's go ahead and select modify to end the command. Next, we'll reset the visibility state of the floors that we hidden just a moment ago. Go back to your temporary hide and reset the temporary state. So the floors are now visible. And let's just take a peek at the properties of the floors. If we left click to place one of the floors in a selection set, I just want to note that the height below the current level is -1 inch, and that the actual floor decking is 1 inch thick. So in this case, we should modify the columns accordingly. And let's take a look at the properties of the right-hand deck. This one's at -8 inches from the current level. So for the columns that we just placed, we're going to modify its top offset. So if we go back to the framing cutaway 3D view, you can see clearly that the columns are protruding above the current deck elevations in both situations. So let's go ahead and correct that. So from this 3D view, let's work on these two columns first. I'm just highlighting them just to let you know. These are the ones that we're going to work on first. So Control left click to place those two columns in a common selection set, and then we'll modify the top offset properties. Once the selection set's been created, go into the properties palette, and for the top offset, let's put in a value of -2 inches. And then click Apply to apply those changes to the model. That looks good. Top of columns are meeting the underneath side of the floor decking. Let's hit the Modify tool to clear the selection set. We'll rinse and repeat here with the other two columns. Control left click to create a selection set of these two columns on screen. And let's set the top offset to -9 inches. And click Apply. All right, that looks good. Go ahead and hit the Escape key twice to clear the selection set. Let's return back to the deck framing plan view. And next we'll continue the process by placing beams around the perimeter of that floor decking system. So just like before, let's go ahead and set the visibility state to hide for these two floor systems. So put them in a common selection set. This time I'll use the right click menu technique in the canvas window. Right click, choose hide and view elements. Okay, now we have our environment set up so we can place beams clearly across those columns. So I'm going to zoom in here a little bit, and then the beam tool is located on the structural tab. Go ahead and click beam. In the type selector, let's go ahead and change that shape to a 2x10 dimensional lumber. Placing beams is like drawing lines. You pick a start point and an end point. I'm just confirming that the chain mode is enabled so we can draw beams back to back as a continuous series of operations. Let me zoom in and pan just a little bit here. We actually want to start from the exterior wall along grid line 1, so go ahead and acquire an intersection snap there and left click, and then click at grid line 1A, and if need be, zoom in to cleanly acquire that intersection snap, and then move your cursor over to grid line 2 and left click at grid 2A. Hit the escape key twice to clear the selection set. And what I like to do is place these two beams in a selection set, and let's modify its elevation offset. So once those two beams are in our selection set, let's go ahead and set the start level offset to -2 inches and the end level offset also to -2 inches. Go ahead and click Apply to apply that to the model. Go ahead and select Modify to clear the selection set. We'll continue on creating the rest of the perimeter beams here. So start the beam tool again, start at grid line 2A, left click at grid 3A, and for the next segment we want to go to grid line 4B. Let's use the keyboard shortcut SI, S as in Sam, I as in India, for snap to intersection and left click at that location, and then we'll end the beam at grid line 4 and the exterior wall. Once those three segments have been completed, go ahead and select Modify to end the command. And next we'll modify the elevation heights of these three beams. So go ahead and Control left click to put these three beams in a common selection set. And in the properties palette, again for start and end offset, let's put in a value of -9 inches. And then click Apply to apply that to the model. For additional practice, model a beam along grid line 2 from the outer column to the exterior wall. I won't demonstrate that. Let's go back to the framing cutaway 3D view, and let's just confirm that the tops of the beams are matching the underneath side of the floor decking. Looks pretty good. In the next exercise, we'll actually place the floor joist to support the floor decking. Let's go ahead and save the file as a new project. Call this one Structural Exercise 1 Finished. Go ahead and click Save to give it a name. This concludes this exercise. Let's go ahead and take a look at next steps. Let's review the learning objectives for video 1. In this lesson, you were able to place columns to support a raised outdoor deck. And then last, we were able to place beams as primary members to support floor joists. With that, let's take a look at Autodesk resources that are available to you. I would like to make you aware of two Autodesk resources. The first resource is the Autodesk Education Community, where you can access free software for both students and educators for titles like Autodesk Revit featured in this series. The website address is www.students.autodesk.com. Registration is required to access the free software using either your personal email address or your school-issued email address. The second resource is the Autodesk Digital STEAM Workshop. It's hands-on, project-based learning across multiple industries such as architecture, engineering, and entertainment. The website address is www.digitalsteam.autodesk.com. Registration is required to download the free learning resources using your Autodesk ID created from the Autodesk Education Community. You will find the Fundamentals of Architecture series under the Subject pull-down menu, Architecture link. Assets include step-by-step instructions, datasets, and videos. This concludes this lesson overview summary. Thank you for watching.